Hi everyone, let's start lesson 33 on hypothesis testing, setups, decisions, and conclusions. What is the structure of a hypothesis test? Let's begin, not surprisingly, with a setup, setting up a hypothesis test. And we have seen the cast of characters. The setup for a hypothesis test includes a null hypothesis, denoted by H naught or H sub 0. The null hypothesis is an assumption that calculations are based on. We can compute probabilities and test statistics on this assumption. The classic null hypothesis we used back before in previous lessons, the coin is fair. Classic null hypothesis. Or it could be something like the mean of the test scores in a class is 70 points, something like that. Something that we can base calculations on. Now, we live in a world where either the null hypothesis is true or the alternative hypothesis is true, H sub 1 or maybe H sub A. Again, the alternative hypothesis is everything that the null hypothesis is not. So for example here, let's see. The alternative may say that the coin is not fair or that the coin is biased. Or for the second one over here, the alternative could say that the mean of test scores, let's say, is not, I'll put not in capital letters, is not 70 points. We live in a world where either the null hypothesis is true or the alternative hypothesis is true. And then there is a claim. This is the first time that I'm really introducing this, really. I've mentioned it before. The idea of a claim. And this depends on the wording of the given problem. I'm going to say in a hypothesis test problem, the claim is da-da-da, something like that. And depending on the wording, either the null hypothesis or the alternative hypothesis could be the claim. And you have to figure out when it's the null, when the claim is the null, and when the claim is the alternative. Sometimes it's one, sometimes it's the other, based on the wording of the problem. And that's the claim that we're testing with a hypothesis test. So we're going to make a decision on what to do with the null, and we're going to make a conclusion. The conclusion of the test will eventually be worded with respect to this claim. So our decision is going to be that we reject or not reject the null, and then the conclusion will be worded with respect to the claim, with respect to the claim that David's coin is fair or not fair. And then, we've seen this before, a significance level alpha. Before I said this was the third ingredient. Here it's fourth in my list. It's the third ingredient to a hypothesis test. Fourth if you include the claim in the wording. All right, so alpha represents the threshold for what it means for sample results to be too unusual for the null hypothesis to survive. Under the null. Remember, we make calculations under the null. And remember the deal. Whatever your value for alpha is, it's usually 0.05, but it could be, say, 0.01 or 0.10. But whatever alpha is, remember, what's the relationship between the p-value and alpha? What was the rhyme? If the p-value is low, the null must go, as in go away. So if the p-value is down here, below alpha, remember before our little game, let's say that we flip a fair coin 7 or 8 times and it comes up heads all 7 or 8 times, then a lot of those judges are going to say, I don't buy that. The p-value is too low. The probability of what we see is too low. Or remember the p-value is like a tail thing, right? Could be like a 1-tail or 2-tail p-value, say, but the probability of getting something at least as unusual as what we've seen. That p-value is so low, the null must go away. like 7 out of 7 heads, for example, if alpha was like 0.1. All right. Now, over here, remember we talked about the null saying that, oh, the coin could be fair, or the mean of the test scores was 70 points. All right. But remember, when we said that the coin is fair, that corresponded to the idea that P, the probability that the coin comes up heads, let's say, was 0.5. Down here, we're saying that the mean mu is 70 points. So often the null hypothesis says that one of these population parameters is equal to some value. That's your typical null hypothesis. The null hypothesis and the alternative hypothesis often say something about the value of a population parameter, possibly a population mean, mu, p, a population probability or proportion, sigma, a population standard deviation, or sigma squared, a population variance. Later on, we will talk about other types of null hypotheses, but the basic old school type of null hypothesis would say the value of a population parameter is some number. The mean is 70 points. P is 0.5, something like that. Okay, now the null hypothesis often states that a population parameter takes on a particular value, and informally, we're going to call this the reference value. That's not an official term, it's just my term. So for example, in the case where the coin is fair, all right, P equals 0.5, 0.5 is your reference value. In the case where mu, the mean is 70 points, all right, 70 points is our reference value. The null says the mean equals 70 points. Okay, the alternative then states that the population parameter, I'll just move this down. The alternative then states that the population parameter does not take on this value. And this is the setup for a two-tailed test. Okay, so that would be like P is not 0.5, or the mean is not 70 points. That's going to be the setup for a two-tailed test. Okay, so let's talk about this. And then later on, we'll talk about other types of tests. But let's talk about a two-tailed test. Example 1, the magician's coin. We want to test the claim that, and you might even want to circle this, a magician's coin is fair at the 0.05 significance level. I'll star this. If you're rushing at the end of an exam and you have to write the claim really quickly, maybe put a star there. Okay, it's like copy paste. We want to test this claim that David's coin is fair at the 0.05 significance level. Whoa, I'm sorry, I made this too big. The magician's coin is fair. A magician's coin is fair. All right, it's a small claim. Okay, we want to test the claim that a magician's coin is fair. That's the claim, that's all it is, at the 0.05 significance level. All right, so this here is, what's the symbol? Fishy, alpha. It's the first letter of the Greek alphabet. It's fishy. Alpha is 0.05, which is standard. Okay, so we could let P be the probability that the coin comes up heads. I guess there are basically only two parameters you could realistically set up. Either the probability the coin comes up heads or the probability the coin comes up tails. Let's let the P be the probability the coin comes up heads. Then here's a setup for this two-tailed test. The null hypothesis says that P equals 1/2. Remember, the notion that the magician's coin is fair, that corresponds to P being equal 1/2. I'm going to erase this. The notion that the coin is fair, that corresponds to P equaling 1/2. And it turns out that's the claim. Based on the wording of the problem, right, we want to test the claim that a magician's coin is fair. The claim is that the magician's coin is fair. Bear in mind, the wording could have just as easily said that the claim was the magician's coin is unfair. And by the way, the alternative is the one that says that. The alternative hypothesis would then say that the coin is unfair or biased. That is, P is not 1/2, meaning that P could either be less than 1/2 or greater than 1/2. Maybe it's biased towards heads or tails. And remember, alpha was 0.05. That's given in the problem. So that's the setup for a two-tailed test. And then later on, we'll talk about methods by which we can come up with a decision as to whether or not to reject the null, and then how to write out the final conclusion. But for right now, we're going to write down the 3 key ingredients based on maybe the 4th ingredient in the wording. Write down the null, write down the alternative, write down alpha. And the way that you write these down depends on what the claim is. The claim is that the magician's coin is fair. That is p equals 1/2, and that's the claim. Now, the reason why this is the null hypothesis is that if you have a statement that says that a parameter like p equals a value, that's going to be the null. And then the alternative will be p maybe is not equal to that value. Alpha is given. Okay, so next video, we're going to talk about one-tailed tests, right-tailed tests, and left-tailed tests, where these look a bit different. Next time.